So this review is supposed to cover everything that's in Chapter 1, the main topic, and our first thing is absolute value equations. So your steps for absolute value equations is to make sure the absolute value is by itself. So that should be the very first thing you guys want to do. And then we're going to use our two cases. All right, first case stays the same. Second case, we always negate what's on the other side of the equal sign. And the big thing at the end, we have to make sure you guys remember to check them into the original. These are the ones like you have to check or no, you have to do it. Okay. So the first step here is to make sure, is your absolute value sign alone?
Oh yeah.
Yeah. So we can go right to our two cases. So case 1 is going to stay exactly the same, just no absolute value sign. Okay, so it looks identical. Case 2, we keep this part the same. So 3x minus 1, whatever's on the other side of the equal sign is going to change. So why don't you guys go through solving now for x. You can just get x along. Did you guys get 2 and negative 1/3? Mm-hmm. Right, good. I want to show you something cool on the new calculators. Right, if you have an updated calculator, I think this is kind of a cool thing. Does everybody have an updated calculator? Are all yours updated? Yours is updated?
I don't know.
Remember how we did? Did we do that? When we did the log, we grabbed that you were able to use the window thing.
Oh, alpha window.
Alpha window.
Yeah.
Okay. There's a cool. I think when you do.
There's the absolute value.
Yeah, you can actually like type it in. I think it's just nice. Alright, let me go back to this one. Calculator than this one. Alright, so if you guys were going to do your check, so if you're going to do your check and you just want to do it quick, right, you're taking your 2 and you're plugging it in here for the x. But if you just want to put it in on your calculator, go to, let's see, alpha, there's a spot where it comes up really quick. Oh, wait, I just had it. Alpha, oh my gosh. Sorry, guys. Alpha window. There it is. So alpha window, this ABS, right, that's your absolute value. Right. So what you can do is get your choice 1 and then type in what you guys would have. So 3 and then times 2. So 3 times 2, then minus 1. And we want that to equal 5, right? Mm-hmm. So that one works. So it's good. Same thing if you want that negative 4/3. So alpha window for our CBS. So 3 times, make sure with your fractions you guys put parentheses around. Negative 4/3. And set aside minus 1. Does that one work? Yeah. So these both work. It's a cool little, just quick way to check.
You do it for a signal.
Yeah, that's cool. So both of these are going to work. So this is just like a general problem. Some of the tough ones I've seen on the Regents exam have been looking like multi-step. So for the second problem, is your absolute value sign alone? Mm-hmm. No, so we have to get it alone first before we do anything. So we want to move this away from this absolute value sign. How would you guys move the 2x? Good, so we're going to minus this. So then we have negative in front. Is it alone? Yes.
No, the minus.
Good, yeah, we got to get rid of that negative sign. Now, to get rid of the negative, does anybody remember how to do it? Divide by -1. Yeah, divide by that negative sign, or -1. Just make sure over here you got to divide each part by -1. So we get x plus 3. This is going to turn into a -9, and then negative divided by negative is a positive 2x. You have to do all this work before you do your two cases, because now the absolute value is alone. So we can go right to our two cases. Then go from here to these. Case 1 is going to stay the same. In case 2, we have two things to change. Make sure you guys change both of these. So it's going to be equaling a positive 9 and a minus 2x. Good so far? Okay. Right, yep, so just solve these like normal. You got to get all the x's to one side, constants to the other. And then make sure we check both of them into the original. When you guys do your check, you check 12. The original equation is way up here. That's 2 times 12 minus 12 plus 3 equals 9. Right? Make sure you guys are going into your original part. And there's two spots where there's an x, so 12 and 2 spots. Really not too bad to just do out. 2 times 12 is 24 minus, that's going to give you guys 15 in the absolute value, which is still just 15. So that's going to give you 9. That works. Let's see, this is 2. Let me try 2. 2 times 2 minus 2 plus 3 times 6. This is going to be 4 minus 2 plus 3 is 5. Did that give us 9? No. No, okay. So yeah, that doesn't work because it's like -1 equals 9. That can't happen. Right? So it doesn't work. We don't take this as an answer. We're going to reject this value. Right? Right, so we're not going to have that. Okay, so just take one number. Do you guys remember these? Yeah, a little bit. Okay, good. Okay. So absolute value inequalities are basically the same exact thing. We got to make sure the absolute value is by itself. We're going to do our two cases again. Case 1 stays the same. Case 2, though, we have one extra step. We're going to negate the other side, and then we have to remember to flip the inequality sign, right, and then solve as normal. Just make sure in case this comes up, remember if you guys divide by a negative number, we have to flip the inequality sign. So if you had something like -2x is greater than 10, and you were going to divide by a negative, yeah, it switches, so you got to flip your sign. Right, so just in case that comes up. Hopefully these are kind of familiar. We've done a lot of review of them. So just check, is your absolute value alone? Yep. So go right to your two cases. Case 1 should stay the same. Case 2, make sure that you're going to flip and negate now. And we're just going to solve them as normal.
Do we just check this one, or do we?
Nope, no checking when it's an equation, but you guys do have something very important. The line?
Yeah.
Okay, you might want to graph it, or unless you can tell what it is. Do you guys remember conjunction and disjunction? Right. We have to write them correctly. Right, disjunction, use the word or between. Conjunction, you had like the x value, and you had it sandwiched between the two. Right? So we have to decide, is this going to be a conjunction conjunction and disjunction, or disjunction, and write it the correct way though. Because if you guys leave it like this, not going to be full credit. You got to make sure you're careful. So that what you were saying, if you graph it on the line, that might help. Okay. What do we have? Open or closed circles here? Okay, good. Right. So x, is it less than 5 or greater than 5? Less. Think about it as eating less, because we're going to go to the left. What about the -1? Green. Yes, Ashley, good job. Okay, so if we have this overlapping, conjunction or disjunction? Good. So conjunction, we have to write it like this. So put your x between. If you guys order it from least to greatest, the signs are always going to go the same way. So -1 is smaller than 5, so make it in the right order. And then you're always going to have your chompers face that way.
It's always that way.
Always that way. Because when you read this, this says x is greater than -1. It's getting chomped with the -1, but this side is smaller than 5. Yeah.
So when you go to the original problem where it's like x is less than 5,
Yep.
could you just like follow the way the arrow is going?
You can't do, well, see how this one? You can't just write it this direction. You have to write it according to the x. Oh, yeah.
Can you just follow the...
Oh, all right, wait, I hear what you're saying. And you have the x on the other side. You have the x on the other side. Right. This means the same thing as this. Right. So see how your arrow would be a different way. So it just depends which side your x is on. You really want to look more to see is the x getting like eaten. Because that'll always work. If it's getting eaten, you go to the right. If it doesn't get eaten, you go to the left. Yeah, with inequality. Alright, why don't you guys try this next one? It's just saying like which one would be the graph of it. Hopefully you can go for the gold here. Hopefully we are at 2 and -1. And then just make sure you guys are careful when you put it on the picture. Make sure it's in order. -1, we got a 2, open circles because of our inequality sign. Remember, if it looked like this and it was an equal to, then it would be a closed circle. So this one's saying x is less than 2 because it's not going to be chomped. So less than goes to the left. Okay, now this one, it is getting chomped, so you're going to go to the right. So we're going to see which one looks like that. 2. Yep, perfect. Good job. Is this stuff looking semi-familiar? Okay. We did a lot of stuff with factoring back in chapter 1, 2. So this is just kind of like a little bit of a review of like factoring stuff, like solving for x. If they ask you guys anything about like what's the negative root, what's the positive root, that just means like which value of x is positive or negative. So at the end, they want to know. Okay. Well, yeah. So whenever you guys have something with an x squared in it, that's your highest exponent. You've got to get it equal to 0 first. And then we want to look to see for some factoring. How would you guys want to factor this? Or GCF? Do you double bubble? Do you have to do grouping?
You don't have to do...
Or guess and check? You do grouping?
I mean, it doesn't matter where you go to.
Yeah, I would probably do, if you're a guess and check person, you could do guess and check, that works. If not, you don't want to go right to double bubble here because you have a number in front of x squared that's bigger than 1. So this would be one you probably want to do grouping. A lot of you guys like grouping. So grouping is where you multiply the two outers, right, which will give us a -12. So we want to think, don't multiply the -12, but can make +1, because that's what the middle one is. 3 and 4, good job. So we got 3 And 4. Good, and 4 would be? Perfect. Not bad. Would that give you a positive 1 when you add them? Hopefully. And it would give you negative 12 all time. Good job. So the idea behind grouping is we're taking out the middle term and we're going to replace them with these two. So we're going to do 2x squared. Well, to set yourself up to make it easier, you want to group the GCFs together. So does 2x squared have more in common with 3x or 4x? Probably 4x. So I'm going to do plus 4x, then minus 3x, then minus 6 equals 0. Just makes it a little bit easier when you factor. So now, you're going to finish your grouping method by splitting it down the middle, and then we want to take the GCF of both parts. So what's your GCF of the first part? 2x. Good job. Right, make your one bubble, and that's going to be an x plus 2. And then on this side, make sure you guys remember to factor out the negative. So negative 3, and then we'll have a x plus 2. Good job. Right. Remember your bubbles should be the same. Common binomial. Good job. All right. So at the end of this, what we're going to do is take the two GCFs, okay, write them together. So 2x minus 3, and then write the bubble one time. Now your last step, if they just said to factor completely and we didn't have an equation, you could have left it like this. But if it says anything like solving for x or like what is the solution, we need to take both of these and set them equal to 0. Good. So this is going to be x equals negative 2. This one's going to be x equals, anybody know what this is going to be? 3 over 2. Good job. Yep. And then they want the negative root, so it's just going to be that one. Both of them will work, it's just going to be specified the negative. Do you guys remember doing grouping a little bit? Yeah. Good. Good. Right, let's see, what is this? This one's kind of similar, so what's the positive root? But before you do anything, set it to 0, good job. Alright, so move that 8 over first. We should have 3x squared plus 5 equals 0. So when you guys do your, if you want to start it, feel free to just follow us. I'm just going to pause the video both. So make sure you guys multiply your outers. So 3 times negative 8 is going to give us a negative. Perfect. Okay, so let's see it. Now to be a factor of 24, negative 24, that can make a positive side. That's what we're looking for. What do you think of that? 8 and 3, good job. We got 8 and 3. Which one needs to be positive though? Which one's negative? You want a positive side. 8 good. And minus 3. Nice work. So we're going to take out that middle part and replace these two in the spot. Organize it nicely so your GCFs are going to have more things in common. So I'm going to take my 3x squared. I'm going to do the minus 3x with this. Then plus 8x minus 8. Once it's organized, cut it down the middle. We're going to do our GCFs of both parts. The GCF here should be 3x. We should have an x minus 1. On the other side, make sure you take out the sign, so the positive 8 as a GCF. And we should have a x minus 1. But remember, bubbles need to be the same. If they're not the same, something is up. So we group our GCFs together. 3x plus 8. And x minus 1. Right, when you set them to 0, you should have x equals a positive 1, and then x equals a negative 8/3. And we just want the positive root, so it's only this one. We haven't done back a lot of that kind of factoring, I feel like, in a while, but hopefully that was a refresher. Right. Alright, so the next one's a little bit different. Anybody have an idea what type of method we have to use to factor something like this? Look at the numbers and like the exponents. That's your GCF. So like if you looked at that, is there something in common with like a 4 or 25? Like they have could 5 go into 4 though?
No.
They're both something special.
Oh, they're I don't know what they're called. Root. Yeah, root.
Perfect squares, good job. And notice the difference of perfect squares is you have the minus between. So when you guys had difference of perfect squares, that's why you guys did your double bubble. And you almost want to act like you're taking the square root. So what's the square root of 4? 2 and 2. Good, so you do 2 and 2. What about x squared? 2x squared. So you're right, 2 is the next part. X and x. What are your symbols? Good. One gets a plus, one gets a minus. And then 25 was 5. Good job. Alright. And what about y to the 4th? What times what would give you y to the 4th? Y squared. Good job. Y squared, y squared. And at the end, we want to look and see, can you do anything else here? I don't think so. That's it. You want to, they'd have to be perfect squares for you to do something more, and there'd have to be subtraction. So this would be it. That's everything. Thanks, guys. I know we're supposed to get our picture at 3. Oh, never mind. I'm probably late. Okay. Now the next part, you guys kind of had done this a little bit already because of your previous grouping stuff. Let's try example 2, just because we're running a little short. Make sure you get out there. Okay. So if you guys have grouping methods, like right off the bat, you want to check to see, well, first I should say that you can tell you have to factor by grouping because right away, when you look at actually both of these, how many terms do you see?
4.
There's 4 terms. Yep. And do you see a GCF? No, there's no GCF, so we can't do anything else. So what we're going to do, if you want to make sure grouping is going to work, for which you guys will see, it will, but if you really wanted to check, if you multiply the outers and the inners, you want to see, do you get the same thing? So like 2x cubed times 6 would give us 12x cubed. And see how the inners, if you multiply those, we get a 12x cubed too. So that's like a clue that grouping method will work. Right? So once you guys have your 4 terms, all we're going to do is split it down the middle. See? Yeah, if you want to, you can. If you want to, you can. I didn't, but it doesn't matter. Usually if these are, the reason why we switched them before is because they were both x's. Yeah, this is like x squared, that is x. So they'll probably write it like that and keep it in like standard form. You don't have to, but it should look the same. Alright, so what's your GCF for the first part? Good, x squared, nice work. Okay, so let's see, what's left in the bubble? Good, 2x. Great job. Okay. And then we're going to do the same thing and take our GCF over here. And make sure that we keep up the sign. Don't forget about that. So negative, good. And then we have a minus 3, good. And again, bubbles need to be the same. Now we're going to take the 2 GCF. Okay, write those together. So we have x squared minus 2. And then 2x minus 3. Okay. Can we double bubble this one again? X squared minus 2. Because of the 2, right? We can't, because it's not a perfect square, so we can't do anything else. This is it. How's grouping method for you guys? Good. Alright, so this is like the last part. You need a calculator for it. It's really easy, but we haven't done it in a while. So, and I'm actually going to put a little bit extra notes on here. Okay. I would do this in a calculator. What we're going to be using is the second test key. Right, and I'm going to show it on both versions of the calculators to make sure it comes out okay for you guys. These are mostly, I don't know, you guys don't have like the plus, right?
Where's the test?
Yeah, I don't think you guys have the The extra one, like the one that comes out with colors when you graph it. No, okay. I think most of you guys have like the regular A4 font. I just want to make sure it looks the way you guys have. So to do this in a calculator, it's way, way easier. So what we're going to do is go to your y equals key, right? And we're going to graph this. So we're going to go to y equals, type in your equation. So x squared minus 2x minus 15. All right, to get the inequality sign, what we're going to do is the second test button. So to get the second test button, right, what you guys are going to go to second. Test is like where the math key is. You see how you get all your inequality signs? So just take the one that looks like yours, run what is 0, type it all in, and then hit graph. So what this shows you guys, is it a conjunction, is it a disjunction, and it shows you guys the values that you should have. So here, you can count. This is -3. This is 1, 2, 3, 4, 5. So would this be a conjunction or disjunction? Conjunction, good. So we're going to zoom out. Oh, you're in trig mode still. Go to zoom 6. If anybody's calculator, if you can't, if it's got the second trig still, go to zoom 6. We'll make it normal. Alright, so what this shows you guys, on our line that we had, -3, we had our 5. Would we have open or closed circle? If you open, good. So it looks like this on our calculator. Calculator doesn't show you the circles. Right? Just make sure you write this correctly. So when I write this as a conjunction, make sure you guys sandwich it in. Right? Put your X in, right? And your arrows are always going to open to the right as long as you have it in order. It's way easier than using a test point. Just notice the difference. Yeah, there's no absolute value here. Right. So you're not doing your two cases, it's a quadratic inequality. So your highest exponent squared, and you have the inequality sign.
Maintaining our test point would be like going through
That test point thing is you have to pick a number. You actually have to like factor this out, solve it, and you have to pick numbers between each section and test them into the original. I'm just going to challenge you. I'll be out like they probably need to be okay, perfect. Oh, even better. All right. Great. I'm going to rush you to get stuff. Okay. Okay, so now this one, why don't you guys try and make sure you put it on a calculator. Second test will give you guys your inequality sign. The conversion to 4. And then 0. See what happens with that. Did you guys all get the right graph?
Yes. Then principles like all graph here, could it be like plotted out too, or you just go until you see it?
This is going to continue forever. Same thing in this direction too. So when you write it, it's going to be, well, would this be a conjunction or disjunction? Disjunction, right? Because you have that gap between. So as to answer your question, this would be like -2.
Oh, yeah, it's going to go inside.
Right, so when you do this, you want to think, when it's a disjunction, right, this one's kind of nice. You're doing them almost like separately. So when you have your x with a -4, are these values less than -4 or bigger? Less than. So when you guys have less than, your x, does it get chunked? No, so x is not going to get chunked. then we have our -4. And then with the -2, let's look here. Is your x going to get chomped with this one? Is it bigger or smaller? What's your value? Bigger, right? So here, the x has to get chomped because we're trying to greater. So it's greater than -2. What?
So it's not a conjunction, so you can't write it from.
Exactly. You can't write it the other way. You don't want to. What do you have to put between them? Or. Good job. Okay, so you have to put that in between to get full credit. Okay, so just make sure you're careful with like your writing stuff.
So like, for instance, the x is like going, or the -4 is going that way, so it's not like big, it's not.
Right, this means less than.
Less than. So if it goes less than it's less than.
Yeah, it's bigger, right?
Yeah.
So if your numbers over here are bigger, it's greater than. Think about like all these numbers would be smaller, like -5, -6, and then these ones would be end up getting greater. It's a little tricky when you do it. So let's put this in that then. And x was 4. 4 bigger than -2, right? Yes. Okay, so the last one's a teeny bit different. I've only seen it come up like one time on any of the exams, and it's more important to do is match it to a picture. So notice the difference though in these two. Do you guys have one letter or two letters? Two letters. We have x's. Here's x's and y. So this is called two variables. There's two letters. The ones up here, yeah, you guys only had one letter, right? So that's one variable. So this is going to be the difference. Now, to make this is kind of nice. You have your y already there. Our calculator's not as great with this. One thing you guys can do is in your y equals key, if you want to match it to a picture, just remember your inequality sign means something. If it's got the line underneath the equal to part, it's going to be a solid line. If it doesn't have anything, it's dotted. So when we go to graph this picture, it doesn't have to be perfect, but let's pull this thing up. So we're going to go to our y equals sign. Get rid of all this other stuff.
Isn't there a way to change it?
It depends what kind of calculator you have. Some people have an application where they can input an inequality sign, but we can all at least change the shading part at least. So with your shading, okay, we have our y, and one thing we want to make sure you guys know, if the y gets chomped, we're going to be shading up. But if not, we're going to shade down. So here, is your y getting chomped? No. So we're going to shade which direction?
Down.
Down. Good. Okay. So it's going to tell us we're going to shade down. To get shading down on your calculator, unless you have something that you can input your inequality sign in here, you arrow all the way over. So it's blinking on that line. Okay. You hit enter until you get the shade down. So this right here is shade up. It's going up. Hit one more time. See how this one's a shade down? Okay. So leave that on the shade down part, and then you're going to type in the rest of this. X squared minus 3x minus 10. So x squared minus x minus 10. Okay. All right, and then we are going to graph this. Perfect. I almost had 2 seconds, and then I will tell you something. No, it's fine. So this is what your graph should look like, right? When you guys graph this, it's going to be like a matching picture. So just pay attention that should this be a solid or dotted line? Solid, good. So when you guys do your graph, make sure you have a solid line connecting, right? And then just pick the one that's shaded like your calculator shades on the outside. Okay, so it'll look something like that. Alright, here's our last one. Let's try this one. Before you guys start, just make a note, would this be a solid or dotted?
Solid.
Dotted line, good. And look at your chomping. Is the y getting chomped?
No.
Yeah, so which way do we shade? Up, good, okay. So here's our shade up. Perfect. Okay, so let's go to the calculator and we'll see what this thing looks like. Your shade up We'll just highlight it and hit enter until you guys get that sheet out part. One more maybe. There we go. So we get something that's kind of shaded on the end. Alright, your calculator won't tell you which way to line, like if it's solid or dotted, so you guys have to pay attention to that. So just make sure we have a dotted line, and then the inside part should be shaded. I've only seen one question with that kind of stuff, but it'll be a matching picture. So hopefully your first review is good.